Post-tensioning in building structures. In order to understand the concept of post-tensioning, we have to know about pre-stretched concrete. In 1928, Eugene Francis developed and patented the technique of pre-stressing. A pre-stressing concrete is a concrete in which there have been introduced internal forces of such magnitude and distribution that the forces resulting from the given external loading are counteracted to a desirable degree. Pre-stressing can be accomplished in two ways. First, pre-tensioning. Second, post-tensioning. In pre-tensioning, the tension is applied to the tendons before the casting of the concrete. And in the same way, post-tensioning, the tension is applied to the tendons after casting of the concrete. Types of post-tensioning. Post-tension floors can be constructed using either bonded or unbonded tendon system. The bonded tendon system. For a bonded tendon system, the post-tension strands are installed in galvanized steel or plastic ducts that are cast into the concrete section at the required profile. Features of bonded tendon system. There is less reliance on the anchorages when the duct has been grouted. Pre-stressing tendons can contribute to concrete shear capacity. And also due to the concentrated arrangement of the strands within the duct, a high force can be applied to a small concrete section. Accidental damage to a tendon resulting in a local loss of the pre-stressed force only and doesn't affect the full length of the tendon. Unbonded tendon system. In an unbonded tendon system, the individual steel strands are encapsulated in a polyurethane sheath, and the voids between the sheath and the strand are filled with touch-inhibiting grease. Main features of unbonded tendon system. The tendon can be prefabricated off-site. Tendons can be replaced usually with a smaller diameter. The installation process on site can be quicker due to prefabrication and the reduced site operations. The force loss due to friction is lower than for the bonded tendons used in the action of the grease. Why a bonded tendon system? Due to high flexural capacity, good flexural crack distribution, good corrosion protection, flexibility for later cutting of penetrations and easier demolition. The main steps carried out in post-tensioning. First, casting of concrete or laying. Second, tensioning of tendons or stressing. Third, anchoring of the tendons at the stretching end. And finally, grouting. The figure shows the steps carried out in a post-tensioning. The A shows the casting of concrete, and B, tensioning of the tendons, and C, anchoring the tendons at the stretching end. The figure shows the procedure of grouting. In this procedure, the cement slurry mixed with silica is pumped in the duct from the grout mixture. Coming to the materials used in post-tensioning. First, we come across formwork. In formwork, we have two things. One is scaffolding and centering. Scaffold is for external works and centering is to hold the slabs. At present, concrete grades of M30-35 and M40 are the most commonly used for the post-tension floors. Strands. The strand is made from 7 cold-drawn high-carbon steel wires. 6 of the wires are helically spun over a straight single strand. The strand is commonly available in two nominal sizes. One is 0.5 inch and the other is 0.6 inch. We use 0.5 inch in commercial and residential complexes and 0.6 inch for cable-stranded bridges. The figure depicts the cross-section of a strand. Ducts. The duct is a sheet for PT strand or a bar. Because of tendon geometry and profile restriction, the duct must be accurately fabricated. Anchorages are used to hold the strands after stressing. Depending on number of strands and where we are using strands in a building, we have different types like multi-strand anchorage system, slab system anchorage components. The main equipments used in post-tensioning are stressing jack, strand threading machine, strand cutter, grout mixer and pump. The combination of mono jack and hydraulic jack is known as a pre-stressing jack. And a grout mixer is used to prepare the cement slurry. Wedges. These are used to lock the strands after stressing. A barrel is in a cylindrical cross-section and the wedges are locked into the barrel. Soffit marking. Soffit marking indicates the tendon arrangement. It indicates that no holes are to be drilled at these marking points. If in emergency, if any holes are to be drilled, it should be drilled at a distance of 100 mm from the point of marking. The table shows the difference between an RCC beam and a post-tensioning beam. The calculations were carried out by us at the design department. At first, there is no difference in the width of the beam. Both are found to be at 1.5 meters in both RCC and a post-tensioning beam. There is a substantial increase in depth of the beam in RCC section of 0.7 meters and also a concrete volume in RCC beam. Also increase in the steel composition in both longitudinal and shear reinforcement. This table depicts the price value for both an RCC beam and a post-tension beam. Overall, the construction of a RCC beam of length 27.147 meters, it took 8.5 lakhs approximately, whereas in post-tensioning it was just 5.5 lakhs. By using post-tensioning, we have saved an amount of 3 lakhs approximately. The primary advantages of post-tension floors over conventional RCC floors may be summarized as follows. Longer spans. Longer spans can be used reducing the number of columns. This results in larger column-free floor areas which greatly increase the flexibility of use for the structure and can result in higher rental returns. Overall structural cost. The total cost of materials, labor, and formwork required to construct a floor is reduced for spans greater than 7 meters, thereby providing superior economy. Reduced flow height. For the same imposed load, thinner slabs can be used. The reduced section depths allow minimum building height with resultant savings in facade cost. Alternatively, for the taller buildings, it can allow more floors to be constructed within original building envelope. Deflection-free slabs. Undesirable deflections under service loads can be virtually eliminated. Waterproof slabs. Post-tension slabs can be designed to be crack-free and therefore waterproof slabs are possible. Early formwork stripping. The earlier stripping of formwork and reduced backpropping requirements enable faster construction cycles and a quick reuse of formwork. Demolition of post-tension structures. The demolition techniques are similar to those of demolition of reinforced concrete structures. The amount of steel used in PT beam is less than that of concrete structure. Therefore, there is less steel to cut. But only in the case of slabs which have been progressively stressed, we have to take extra precautions to avoid upward bursting of the concrete. Coming to the conclusion, there is a definite trend towards large spans in building due to the fact that there is now more emphasis on providing large uninterrupted floor space, which can result in high rental values. Post-tensioning is an economical way of achieving these large spans. For spans above 7.5 meters and over, post-tensioning will certainly be economic, and as the spans increase, so do the savings. References: Indian Standard Code 1343 of year 1980. Technical Report 43 by Concrete Society. Post-tension concrete floors by Sami Khan, Martin Williams. And also Design of Pre-stretched Concrete Structures by Krishnam Raju. Internet, Wikipedia.
Thank you.